From the very first moment you hear Elon Musk say, "We want to make an awesome driving experience. Make it kick-ass for the drivers," you understand something important. The entire Tesla Model 2 project was built around joy, around feel, around the idea that even a compact, affordable electric car shouldn't feel basic. It shouldn't feel like a compromise. It shouldn't feel watered down. Instead, it should feel playful, confident, interactive, and premium enough that people forget they're sitting in one of the most affordable electric vehicles in the world. That single philosophy is what shaped not just the exterior design or the performance specs, but the very seat you sit in, the posture you maintain on long drives, and the instinctive comfort your body feels even when you don't consciously realize it. Most automakers design seats as isolated components, like chairs placed inside a metal box. Tesla didn't. They redesigned the entire seating ecosystem before even touching the design of any individual seat. Approaching the interior of the model, to the same way SpaceX designs its crew capsules, treating the cabin as a living, breathing system that adapts to human behavior. This begins with a radical question. What if a cabin could adapt to people instead of forcing people to adapt to the cabin? To answer it, Tesla collected biometric data from more than 30,000 individuals of different ages, body proportions, and sitting habits. They monitored subtle micromovements during normal drives, how adults slightly shift their weight after 30 minutes, how children naturally lean when they fall asleep, how older passengers rely heavily on grip points when entering or leaving the car, and how families adjust posture during braking, acceleration, and lane changes. This research showed that comfort is not defined by softness or padding alone. True comfort comes from how the cabin learns to anticipate and react to these tiny behaviors over time. The Model 2's interior team discovered that adults unconsciously rotate their hips by 2 to 5 degrees during longer trips to relieve pressure from the spine. Children begin adjusting their shoulder angle naturally as they grow. People tend to readjust foot placement after traffic lights, and passengers instinctively brace during cornering. Using this biological data, Tesla created a seating ecosystem where no seat works alone. Every seat supports the others. Seat heights were carefully staggered to improve sightlines and reduce motion sickness. Cushion densities were tuned so that pressure transfers during braking and acceleration feel consistent across all rows, preventing the seesaw effect that plagues most compact electric cars. Even the incline of the floor, something nearly every automaker overlooks, was modeled around blood circulation, reducing long-distance fatigue. This holistic approach is where the SpaceX influence becomes clear. Instead of reinforcing each seat individually with heavy materials, Tesla built a continuous vibration dissipation path directly under the floor rails. This reduces vertical vibration by 12 to 18% before it ever touches the seat cushion. It's similar to how SpaceX manages launch vibrations across the entire capsule frame instead of placing shock absorbers under each astronaut. As a result, the Model 2's driver's seat, passenger seat, rear bench, and even the integrated child seat feel like they belong to one synchronized system. Every movement feels connected. Every transition feels natural. And every type of user, from young kids to adults to older, users benefits instantly. But to fully understand how revolutionary this is, you have to look at the Model 2's driver's seat specifically. Tesla increased the width of the seat by approximately 6 to 8% compared to the Model 3, bringing the width to around 58 centimeters instead of 55. This isn't about looking bigger. It's about distributing body pressure more evenly so drivers don't feel concentrated strain on the spine. Middle-aged American drivers, a group Tesla heavily studied, often suffer from back pain or leg numbness during long trips. Tesla's simulations show that this updated width and shape reduce pressure concentration by 22 to 5% during drives longer than 2 hours. The backrest height of roughly 65 centimeters and the 7-centimeter cushion thickness work together to spread body weight more evenly, preventing pressure from focusing on the lumbar area. Even the thigh support has been extended by 2 to 3 centimeters for drivers taller than 1.75 meters. Improving blood flow and reducing leg fatigue, Tesla even recommends a 2 to 3 centimeter a gap between the edge of the cushion and the knees for optimal comfort. Something as small as this, something most people never think about, can eliminate thigh numbness entirely. Tesla also suggests adjusting seating position around 20 minutes before starting a long drive so your body has time to settle into posture alignment. These micro adjustments create a massive difference in overall comfort. Then comes the seat's posture stability, especially during rapid or unexpected maneuvers. The Model 2 seat frame uses a dual reinforced structure with high-strength steel applied to both sides. Tesla's lateral load simulations show about a 15% increase in frame rigidity during sudden steering inputs. This means your body stays more stable, which directly improves steering precision and confidence. You're not fighting your own momentum. The car becomes part of you. Tesla also followed a minimalist philosophy for the seat adjustment system. They removed unnecessary adjustment directions and focused only on the ones people actually use. A sliding range of 25 centimeters, a backrest tilt of 15 degrees, and a thigh cushion lift of 5 centimeters. These provide enough range to accommodate most American adult body types without overwhelming users with too many controls. All adjustment buttons are grouped by function and placed intuitively, so older passengers can learn them quickly and memorize them after a few uses. Entry and exit comfort is also important. The seat pan sits approximately 40 centimeters above the floor, 3 to 4 centimeters lower than a typical car seat. This subtle tweak reduces knee strain by up to 30% when entering or exiting the vehicle, something older passengers immediately appreciate. Tesla even recommends simple two-side leaning tests to check whether the rails and frame are functioning correctly. If the seat remains stable and quiet, the system is working as intended. The mechanical structure is just one part of Tesla's innovation. The seat materials themselves were re-engineered from scratch. Instead of relying on traditional polyurethane foam, Tesla developed a more breathable, flexible, durable foam layering system, similar to the seat materials designed for SpaceX Crew capsules. The internal foam is segmented into microzones that compress at different rates depending on body weight distribution. This is why the Model 2 seat feels supportive without feeling stiff and soft without feeling mushy. It intelligently adapts under dynamic loads, something Tesla performed thousands of simulations on using real-world driving conditions. The upper layer includes anti-microshift material, preventing tiny sliding motions that usually cause long-term discomfort. While most seats allow the driver's body to slowly drift or slide over time, Tesla engineered the Model 2's seat surface to hold posture stability while still allowing natural micro-movements. This keeps your body aligned and reduces fatigue. Even heat distribution was redesigned. Instead of heating coils placed under thick foam, Tesla embedded conductive channels into the foam itself, providing faster heating with lower energy consumption while maintaining uniform warmth across the entire seat. Tesla also redesigned ventilation. Instead of forcing air through small perforations like most cars, Tesla uses micro air channels within the foam, allowing ventilation to flow across a broader surface area, improving cooling performance during hot weather without increasing fan noise. Tesla's tests show a 30% improvement in cooling response time. Now think about long-distance driving. Most people don't realize how much vibration fatigue their body takes in through the seat, because the Model 2 is built on a structural battery pack design with a stiffer floor and lighter subframe. Tesla focused heavily on how vibration enters the cabin. Instead of letting vibrations travel up through individual seat supports, Tesla created a unified vibration dissipation channel under the floor rails. By absorbing vertical and horizontal vibration forces earlier, Tesla ensures the driver never experiences the jittery sensation many compact EVs struggle with. Tesla even tuned the seating ecosystem to account for weight distribution across rows. For example, when someone sits in the back seat, the system automatically adapts cushion density response in the front seats, so pressure transfers feel consistent. The Model 2 is engineered not just for individual comfort, but for cabin-wide harmony. The rear seats benefit from this system too. Children naturally shift posture every few minutes, and parents often need to reposition seatbelts or adjust booster seating. Tesla analyzed hours of real footage to build a rear bench that supports children's natural posture changes without compromising safety. The bench includes a subtle central spine support that distributes load evenly during cornering so kids don't lean excessively. Meanwhile, the integrated child seat uses reinforced anchor points in the floor rails, not the seat frame, making it far more stable. Parents immediately feel the difference when installing child seats: less wobble, less pressure on the car's seat.